Why is DHCP critical for PG operating system deployment? Imagine turning on a computer that needs a new operating system installed over the network. It starts up, but it doesn't know where to find the instructions. That's where DHCP comes into play. When a device tries to boot via PG, it first needs an IP address to communicate. Without DHCP, it would be like trying to call someone without knowing their phone number. DHCP, or Dynamic Host Configuration Protocol, automatically assigns IP addresses to devices on a network. But it does more than just give out numbers. It also provides the device with important network details like the subnet mask, default gateway, and sometimes even the location of the PG server. This is essential because the PG client needs to know where to download the boot image to start the operating system installation. Think of DHCP as the traffic cop directing the device to the right place on the network. In PG deployment, DHCP can be configured to send special options. These options tell the device that it is a PG client and where to find the boot server. For example, it can specify the server's address and the file to download. This process makes sure the device can locate the right resources without manual setup. If DHCP isn't working properly, the PG client won't get an IP address or the correct instructions. It will be stuck trying to connect, and the OS deployment will fail. That's why troubleshooting DHCP issues is so important. You need to check if the DHCP server is running, if the correct options are set, and if the network ports are open. In broader networking terms, DHCP helps manage IP addresses dynamically, which is vital for large networks. It makes sure devices get unique addresses without conflicts and can find their way around the network easily. For PG, this means smooth, automated OS installations across many computers. Organizations that deploy operating systems over the network must ensure their DHCP servers are configured correctly. This includes enabling specific options like Option 60, which identifies PG clients, and making sure ports 67 and 60, a UDP, are open for DHCP traffic. If DHCP and PG services are on the same server, extra care is needed to avoid port conflicts. In short, DHCP is the backbone that supplies the network setup and boot instructions needed for PG to work. Without it, the process of deploying operating systems over the network would come to a halt. It ties into the core ideas of IP addressing and network routing, making it a key part of how the internet and data centers operate efficiently.